I'm here to talk to you about a choice in your career, in your growth as a developer. So you can choose to look for something that will give you a simplified view of reality, maybe more pleasant. So you will look for a framework that will help you write your apps. And if you choose this path, you choose to become good at using the framework. And you will have plenty to study, plenty to learn, and you will become the developer that's good with frameworks. And that's a path. I'm not saying this is bad. I'm saying that there's another choice. You can choose to deal with reality at a deeper level. And if you choose this path, you choose a career of learning and studying at a different level. And if you do this, you will gain a leverage that I don't think is possible in the other way. I think that if you choose this path, you may even gain superpowers. Now, I don't want to kid you. There's a lot of controversy, a lot to think about, and a lot of engineering trade-offs to be made. And I'm not saying that you must avoid frameworks always at all costs. Every engineering choice has properties. So if you choose to use a framework, you will have some effects. And if you choose to do without, you will have others. So one of the main things that I think stops developers from having the option, and I'm talking about the option, to work frameworkless, is that perhaps we don't know how. So I wanted to give an example of how you can take a fairly simple but typical Spring and JPA application and write the same functionality without the frameworks. And so you'll get to decide if you like the result, and also you can try to experiment and do something in the same way or in a similar way, because if you choose to go without frameworks, you will have to find your own way. I mean, my solutions will not be your solutions, and my team's solution will not be your team's solutions. And so this is the example that I want to present to you. The game of Hangman is a very simple game. You guess a word by guessing the letters of the word. And the service that I wrote is a simple JSON web service. You initiate a new game by sending a curl command, a post HTTP command. So you're given a new game ID. Then you can play the game by guessing. So you send a guess with the post command. And if you guess one of the letters correctly, the letter will gradually, the word will gradually become revealed, and so on and so forth. So I have 3 versions of this service. One is written with Spring and JPA, one with the Spring without JPA, and one without Spring and without JPA. And they're all available in the repo. But first, I want to show you one thing that, for me, changes everything. So this is when you start the Spring JPA version. You can guess what happens. Spring starts. And even for a very simple application like this, it's painful to wait for the application to start. This is the other version, the one without Spring and without JPA. See what happens when you start it. Perhaps you didn't see it. It was too fast. Again. So think about your day as a developer. How many times, once you're seated at your place, in front of your keyboard, in front of your display, think how much time you have that's focused and concentrated on developing in your day. So you have to take away time spent at the coffee machine, time spent in stand-up meeting, developer meeting, business meetings, whatever meetings, time spent answering email, answering Slack, answering whatever. So now you're in front of your computer, and it's only you and your code. And you wait for the application to start. Then you change something, and you want to see if it works, and you wait for the application to start. And every time you get this 7, 10, 20 seconds chunk out of your best time in the day. And this does not only happen when you keep starting the application. You also pay this price when you start unit tests. Because when you work with Spring, many of your unit tests will need to start the Spring context, which takes time and makes running the tests slower, makes test-driven development painful. So this is one of the many things you have to balance when you decide the framework or no framework. But this one, for me, is a game changer. Now, back to the slides. So, this is how a fairly typical Spring JPA application works. So you have some Tomcat application server that you don't see because Spring makes it for you. Then you have a Spring MVC servlet that you also don't see because Spring makes it for you. Then you write a Spring controller, a REST controller, something like that, which is a fairly simple piece of code, or should be, which typically talks to a service that depends on Spring also. And then it talks to domain objects that, if you're good, should be independent of Spring, but probably will be dependent on JPA. And then you have a repository, which of course depends on JPA, which talks to some entity manager that talks to the DB. Okay, so this is the controller for this game. And the most interesting method to me is guess, the one that changes the state of the game. So when you guess one letter, sorry, what happens is that you make a test, and then you find the game in the repository, then you apply the guess to the game, and then you return a game response, which is a data structure. So there's a lot that is not seen here. So you see that something selects this method whenever a post request is sent to a particular path. Then the path variable is extracted. The request parameter is also extracted and are provided conveniently to you as arguments, as parameters to this method. And one other thing that you don't see is that when you return an object, this object is serialized as JSON, because there's an annotation that says you should return JSON. And then you also don't see that the state of the game is updated in the repository, because this method is transactional, and so it will automatically save any JPA object that is changed. Nothing strange. This is bread and butter to most Java backend developers. And this is the prisoner, which is the main domain object. So it's a simple thing that has a set of misses, a set of hits. And when you guess, it checks if the word contains your letter. And if it does, it's a hit. Otherwise, it's a miss. Simple. OK? So if my English is not clear, just stop me, and I will try to clarify. I can also summarize in Italian. And this is the game repository, how you test it. You need to have all these Spring annotations to make it work. And it takes 7 or 8 seconds to start, typically. And this is the game repository, which is very simple thanks to Spring and JPA. OK. That's the old world. What happens when you decide to do without all this stuff? You have to do some work. So this is how it looks from a high-level point of view. So you have an embedded jet, in my case, which I instantiate explicitly. Then I have a servlet that I write. Then I have a router that I write. Then I have an application service, which is more or less similar to the previous controller. And domain objects and repository. Domain objects is similar to before. What changes is the repository, because we need to do the work ourselves of saving the stuff in the database. What turns out is that all this is not difficult. This is all very easy code to write, and is also very easy code to test drive from with TDD, with tests. And the tests are very fast. Even tests that go with to the database are very fast. And here's one of the tricks that you might want to learn if you want to go this route. So I think that one of the fears that we have when we abandon the familiar frameworks is, will I be able to write good code? Yes, you need to learn to write good code. And this is a part of the interest of doing this thing. You learn to write better code, to design code better. So this is one simple trick that I usually use when I do this sort of work. You know that a Java web application transforms an HTTP servlet request to a HTTP servlet response, more or less. But these two objects have 50 plus methods. They're very uncomfortable to use, and they are very low level. So we transform them first into something that's more convenient. So these web request and web response are classes, objects that I build for my project. Probably I have something similar in several different projects, but not the same exactly, because of the needs of particular needs of any service or project. So these are views, if you like, that provide me a simplified and a higher level view of the request with just the convenient method that I need for further processing. And this is still not enough. So when we get to processing a guest request, I want to have an object that represents the request more precisely. So I create, in this case, a guest request that contains the letter, the game ID, and probably other stuff. If we want to do something realistic, we want to save the time of the request, the IP address it came from, and these sort of details, which are not relevant for the logic of the program, but are necessary for auditing, security, etc. purposes. And then we transform this guest request into a game response and an HTTP status. Then those are transformed into a web request that is transformed into, or better, interacts with an HTTP servlet response. And this is how it looks. So this is the main. Here you see how you create a sort of embedded Jetty, which is a class that I use and is probably unmodified in 7 or 8 different projects. Because the interesting part is the servlet. The Hangman servlet is the other part of the main partition, as Robert Martin, Uncle Bob would call it. It is 2 mains, essentially. One main starts when service starts. The other main is executed for every request. So for every request, in the end, what happens is that we have an Hangman router that routes the request. Routing means finding what method should be executed to satisfy the request. Then we have a web request and a web response that wrap the native Java servlet objects. Then we have the Hangman router, which needs an Hangman service. The router finds what method to call in the service. And the service is created with the game ID generator and the data source. And the data source is created from environment variables, whatever. OK? Is my code clear enough? So here's the router. Essentially, at first level, we try to execute a request. And if it's OK, we are finished. Otherwise, we either have a client error, which is a class that I wrote that basically means the request has a problem, so we return 400. Anything else is an error in my system, so we return 500. And here you see that the web response and web object has a convenient method to handle these cases. So we don't complicate the router with this. And the meat of the router is here. So in a simple service, you have a chain of ifs. Eventually, if the service evolves into something more complicated, it usually looks like a table where you say, when do this, when do on this other path do that, etc. A table-like structure. But still, it's less than 20 lines of code to execute. So essentially, you see that every request here is quite concise because web request has this method that is convenient for checking if the path of the request matches what I pass here. And I can also ask the web request, give me the, yeah. We can ask the web request to give me the path parameter, but this is hidden because we create a guess request from the web request. And then we execute a guess on the service. And basically, that's it. And think that for maximum 4, 5 ifs, it's OK to use an if chain, then you should start looking into something like a table. And this is how the service works. So you get a guess request, and you extract the game ID, and you use it to obtain a game from the game repository. Then this is an optional, so you want to throw an exception if it is not found. Then you get the prisoner, which is the domain object that executes the game, the rules of the game. You call guess on the prisoner, and the game is changed as a consequence. So you save it back in the repository, and then you create a game response. Done. So of course, the details are in the prisoner object, which has a set of guesses, and the guess is simply a wrapper around a letter. And the logic is the same as before. And the repository, which is used here to save our code, our game, basically has a simple SQL statement. And the query runner is an object from the Apache DBlib library. You can do without. I mean, doing this without DBlib is maybe 5 or 6 extra lines of code. So it's not very complicated. But DBlib is a library, not a framework, so it's convenient to use. And basically, that's all there is to the code. So if you want to see what the web request looks like, it's simply convenient methods. Like, you know, often we write code like if the parameter is null or empty, then you throw an exception. And this complicates every controller that we make. So you can simplify by telling the request, look, I want this parameter, and this parameter is mandatory. So if the parameter is not there, you please send an exception back to the customer, to the client, sorry. And so this get mandatory parameter creates a bad request exception, which is a client exception, which in the router will provoke the web response to be called with client error, which will return 400 something to the customer, to the client. And if a parameter is optional, now we don't want to deal with nulls in code. Nulls are disgusting. So we turn the optional parameter into an optional string, and then we can use it to decide, do we want to do something different for present or not present? Yeah. And this is the guest request. So it's all fairly simple code. So the point is, one thing that you often hear is that, OK, this is cool. It works because it is a toy problem, toy example. But I once heard someone say something that struck me and said, when you have really well-factored code, it looks like toy code. So this is not very simple because it's a simple problem. It's very simple because I took some time to make it simple. I took some effort and I worked on it for quite a bit of time to make it look very clean and simple. And this turns out is transformed into a savings of money and time for our customer. Because if our code is clean and simple, then it takes less time to maintain, less errors, and therefore less money spent on development. And these are some data. So when I did these experiments, I started with about 360 lines of code, excluding comments and blanks. And when you turn away, remove a JPA, it becomes 424. And when you remove also Spring, it becomes 643. Now, it's doubled, but I don't think this will hold for a longer program. So if I had a bigger Spring program, say 2,000 lines, I don't think I would take that program and make it 4,000 lines. I think it would be a bit much more less, because we pay a little bit for writing the servlet, for writing the embedded Jetty, for writing the router. But this is not something that makes you write double the code for everything. It's just a price that you pay once. And you have an amazing reduction in startup time. So startup time is always 4/10 of a second. Always. While Spring and JPA has a variable time. Sometimes it's 6 seconds, sometimes 8. 6 is the best time I was able to get. And tests also. All the tests of the no Spring and no JPA application run in 1 second total, compared with 10 seconds for, well, no, 3.5, I'm stand corrected. So 1 second is the time to run the slowest test. So you decide, is this worthwhile? I think it is, because when you have the Spring JPA version that has only 300 lines of code, in fact, you have millions of lines of code that you are using from Spring that might bite you, because as an average developer, you are not sure what they do. So yes, most of the time, Spring is an abstraction that works and gives you a simplified view of programming. But when it doesn't work, then you have to look under the hood and understand why Spring is not doing the thing that you want to do. And that takes away time. And it's time that you spend looking on Stack Overflow for answers. And this is pure waste in terms of lean. It's time that is not spent delivering value to your customer. It's time spent guessing what set of configuration parameters work, and you don't know why. In the end, after a few hours of trying to get things to work the way you want, you finally get something that works. You are not sure why it works. Not always, but sometimes it happens. And I think it happens with a certain regularity in my experience with Spring. I'll be quick to say that I'm not very good with Spring. That's true. But I've seen this happen to other developers too, so I'm not alone. One of the difficulty you have is when you're not just using one framework, but since you are working to solve some real-life problem, you must add other things. And these other things that you add interact weirdly with the first framework that you chose. So when you have two frameworks or two complex libraries that you have to interact, then you start to experience problems. So see on Stack Overflow how many questions are, how can I get Spring to work with X? There's very many. So now you tell me, engineering is about trade-offs. Trade-offs is about having options. Knowing how to do without Spring and JPA is an option that is valuable to have, because if you do, you can write code that's much closer to the metal and has no surprises, has much less risk. Because when you embrace a framework, when you embrace a collection of frameworks, you take on a huge amount of risk. You risk that the frameworks don't do what you expect, don't behave the way you want, don't perform well enough in a certain situation that is important for you. And certainly, you risk that your choice of frameworks becomes obsolete, and then the investment that your customer makes becomes a legacy in no time. So you're still on a Spring Boot 1. You have to update. Now, it's cool that the Spring people do this work on writing cool frameworks. I admit, they do awesome work. But when they publish Spring 2, they give me and my team and my customer an amount of work to do that has nothing to do with my plans and my customers' plans. So whenever framework authors upgrade to a new version, they offload an amount of work on everyone else that was not planned. And if you don't do that, then after a while you have problems because the other plugins that you're using are becoming obsolete and no longer supported, et cetera, et cetera. So you better keep up to date with your frameworks. This extra work. And one other aspect that I see is a bad habit. Like, I don't like it when for every problem, the answer is, what framework solves it? I prefer to see people reasoning on what is the nature of this problem, how can we solve it, is there a solution that does not involve adding more stuff to the dependencies? And that's about it. So what do you think? Does it make sense for you? I expect this is a very controversial, very different from many other talks that you hear at Codemotion. So I really would like to hear from you what is your reaction, what is your doubts, and whatever. Do you have questions for me? Yeah. I will. So can someone give a mic to this person?
Who is over there? Yes.
Hi.
Hi.
I understand why you want to get rid of frameworks. Makes perfect sense. But we also know that frameworks kind of help you not face problems people have faced in the past. You're going to build upon someone else's knowledge. Someone else is falling down.
Yeah, yeah.
How do you reconcile that?
So that's true. Frameworks contain knowledge. This is a good point. And in fact, I learned a lot by using frameworks. So this is one valid use of frameworks. You use them to gain experience. So the solutions in there is something that you learn, and then you can also find a way to use the same solution without the framework. So it's one valuable option. So there are others valid reasons to use frameworks. For instance, if you start a new project, starting with the framework gets you up to speed in a much faster time. Like in one day, you have something that works. In the no-frameworks way, perhaps you need 2 days, maybe 3 days. The question is, does this make a difference over a 3 months project? I don't know. That's up to each one of us to decide. So does this answer your question? Thank you. Any other?
My question is, what do you do when you find a bug in one of those 6 or 7 other projects where you wrote yourself some components, and you find a bug and you want to fix that on the copy and pasted code on other projects?
Oh, yeah. So the question goes like this. So if you have the strategy that you always write your own stuff different for every project, or even worse, if you copy and paste from one project to the other, then you have a bug in your logic, and you fix it, but then you have to apply the fix everywhere else. True. One thing that counters this is that the code that I write in these sort of things is so simple that doesn't have a lot of bugs. So, and the other thing is that if I'm doing something that is complicated, then I will probably fork it to a library. So, for instance, in last year we were working on Spring and Boot, and at some point there was a bit of complicated logic to log, because Spring does 90% of the work for you, and then forgets to do the 10% most important thing. Like in Spring Boot, I haven't found a way to log out of the box that works the way I want it. Because there's a class that does it, but then doesn't log the return, the HTTP status. So I can't use it. I need to log the HTTP status of the response that I gave. So we have a small library that did some observability stuff, like a common exception handler, a common logging function, etc. And these ones were complicated enough. Yeah, nothing, no rocket science, but still complicated enough that we wanted to share it in several different Spring services. So we made a small library. And we use the open source model. Like in our GitHub, we have our private libraries, and we include them in the project. So this is one simple way to do it. Do like open source. Anything? OK?
Sorry. Hi. Well, as a technician, your theory is perfect for me. I very like it, and it is also funny for my point of view. There is only no some problems. I think that the most important problems for me, for our company, for our experience, is that actually now we are changing this approach. My company is composed by more or less 100 employees, and with this kind of approach, we had a lot of problem in the onboarding phases. I mean, for a junior developer that want to start with us, or want to start working with us, in my experience, what I see during this, I'm working in my company from starting from 15 years ago. Typically, a junior with this kind of technology took 1 year.
Wow.
8 months, 1 year to become productive. For this reason, now we are moving to use the much more, as I can say, mainstream framework instead of using our custom frameworks. Because our hope is that the junior employee can use his scholastic knowledge to start approach. What do you think about these aspects?
OK, so this is real. I applied this, our team applied this approach to an important project a few years back. And one of the things that they report to me is that new developers don't like it because it's not cool. There's no cool framework to learn. There's nothing you can put in your CV. So if you put in your CV that you know Java servlets, well, meh. It's not very exciting, but so one of the problems that they have is to motivate developers to appreciate this sort of thing. And I don't have a good answer for this, but I do have an answer for the words application, I mean, our own custom framework. So what I'm advocating here is not that every company builds their own framework, because framework means that you are solving more than one problem, more than one application problem in one single place. And this makes your thing more complicated. So if I have to, yeah, of course, your company is not everything. So your company has a set of problems that is probably related to one another. So it's not like a Spring that has to be everything to everybody. But still, if you go the route to make our company's framework, it's going to become more complicated than necessary. So this goes against my goal, which is to have the simplest code possible. So one thing that I should stress is that I grew up with extreme programming. And in extreme programming, we try to write the code as simple as possible. And if you do this, you don't aim to extract a framework from what you do, because the second project will do things slightly different. So it will have something similar to this, but the details will differ. And by not having a common framework, we avoid the problem of what happens when we upgrade the custom framework, we find a bug, and all these sort of things. No. I think that we should avoid writing company-specific frameworks. It's OK to have company-specific libraries, because a library, compared to a framework, does not mandate a way of working. So framework means, to me, means OK, you don't know how to design your system, I will tell you how. You follow my rules and you'll be okay. A library doesn't say this. The library says, I know how to solve this problem, and if you call me with the appropriate parameters, I will solve it for you. So there's a big difference between frameworks and libraries. Think encryption. I would never try to write my own encryption library because it's very difficult. It requires a lot of domain-specific knowledge that I don't have, and a lot of skill that I don't have. So I use a library. But I will try to avoid to have an encryption framework because that would imply that I have to work in a certain way that at some point might become a straitjacket, something that is not convenient. So I think I have a partial answer to what you were saying. So I know that some companies have their own internal frameworks, and these tend to become a problem because, to put it simply, they are not as good as Spring. And they have the problem of frameworks without having the support and the kind of quality that Spring can have in its framework. So I hope I have answered your question.
You already answered. So, are there any more questions? I have a quick question. When actually do you think frameworks make sense to use? Like, do you see any examples?
It depends on your situation. So, as I told you, I spent the last year and a half working with Spring Boot because the company I worked for, they believed in it, and this was not the best fight to have. So I pick my battles. So it depends. So if everyone is a Spring Boot fan, it's no use to try to get them to use something else. I would focus to try to get them to use Spring wisely, so avoid abusing it and knowing when to write things that must be independent of Spring. And yeah, also when you don't have a lot of experience, it's good to try to write something with a framework. It can teach you a lot. I learned a lot from Rails, for instance, and I think that the whole programming community has learned a lot from Rails and Django because these showed the Java people how to simplify their stuff. And yeah, so it depends. But generally speaking, growing older and more experienced, I try to use as few frameworks as possible. And even if I have to try to use something that's very simple, like Sinatra instead of Rails, like Flask instead of Django, like Spark instead of Spring MVC.
Hi, I have a couple of questions. First, how much time do you need now to document all the low-level code that you write instead of using a mainstream framework? And does it kind of cancel out the app startup time and test running time that you gain?
I believe that my code is simple enough that doesn't need the documentation.
Okay, and I have another question regarding the upgrades. You kind of argue that upgrades are bad and produce additional workload. But if we take that out, isn't that how we end up with a 10-year-old code base that no one wants to work with?
Yeah, a 10-year-old code base can become a mess no matter if you use frameworks or not. So it takes care, work, and attention to keep your code fresh and well maintained. So it doesn't depend on frameworks or not. It depends on your coding habits or the fact that you keep refactoring and cleaning code. And you can also do that with frameworks. And it becomes very important when you do it without frameworks. But I think that 10-year-old code bases are challenging for anybody in any organization.
Just a question. In the everyday life, often the customer decided the framework, the technologies that a company can use for develop the software. How have you convinced your customer for change this approach?
So a customer can have good reasons to not want every new development to start in a different way. So yes, but on the other hand, why should every development be done the same way? If there's a better way, so you need to have some amount of experimentation in your portfolio of projects. If you always do things the same way, you never learn new ways of doing things. And you have to negotiate. Generally speaking, a few years ago, I would have told you, the customer must not make technical decisions, but I don't think it's right because some technical decisions have business consequences. So if everybody uses a different database management system, that's a load of work in maintenance and operations that the developers offload on the company. That wouldn't be right. But it's a matter of negotiating. So if you can show the benefits, like in my opinion, if you know how to do it, Frameworkless gets you to do the work faster. And it's something that the customer might want to listen to.
Thank you, Matteo.
Thank you all.